Question number 10 presents a rather challenging situation for using our dilution equation. If you look at the question here, this is definitely a dilution problem. We have to take some amount of 71% nitric acid and figure out how much of that we're going to need to prepare 10 liters of a 2.00 molar nitric acid solution. While this is definitely a good candidate for our dilution equation of C1V1 equals C2V2, the additional challenge presented here is that our concentration isn't in the same units. So for our problem, we have to figure out how many liters of the concentrated nitric acid are going to be needed. The information portion of this stacks up pretty much like a dilution problem. Our initial concentration, our C1, is 71% by mass. We would like to have a 2 molar solution, so our C2 is 2.00 molarity, and we need to have 10.0 liters when we're all done. What we need to figure out is how much of the 71% solution we need to use in order to dilute it to 10 liters. Our problem here is right over here. Since these units don't match, we're going to need to convert 71% into molarity before we can use the C1V1 equals C2V2 equation. Fortunately, we are given the density of the 71% nitric acid solution in the problem. We're told that it has a density of 1.42 grams per milliliter, and we're going to need the molar mass of HNO3. I just used my periodic table, added up a hydrogen, a nitrogen, and 3 oxygens, and came up with 63.028 grams. Now that I've gathered some information, I have to start to think in terms of how I want to solve this problem. The first thing I need to think about here is what does the 71% by mass means? The 71% by mass means that there are 71 grams of HNO3 in every 100 grams of solution. But I don't need grams of nitric acid per grams of solution. I need moles of HNO3 per liter of solution. I'm going to try to think this through in 2 separate steps. I'm going to take 71 grams and convert that to moles, and then as a separate thought, take 100 grams of solution and convert that to liters, and then I'm going to divide the two to get my molarity. So here are those parts. 71 grams of nitric acid to moles, 100 grams of solution, using the density to get to milliliters, and then on to liters. And then if I divide those two, I will get molarity, which is moles per liter. And finally, at that point, I'll be able to use the C1V1 equals C2V2 equation because C1 and C2 will be expressed according to the same unit system. In my next move here, I'm going to do exactly what the plan said. I'm going to take my 71 grams, convert that to moles. So I've got 1.1 moles of HNO3 at that point. And then I'm going to take my 100 grams of solution and convert to liters. I had to use the density. 1 milliliter weighs 1.42 grams, and that came from my problem. And I figure out that I have 0.0704 liters of solution. So essentially what I've done here, I have pretended that I have 100 grams of solution. In that 100 grams of solution, I have 1.1 moles of HNO3, and my 100 grams of solution has a volume of 0.0704 liters. Now to figure out the molarity, I simply have to divide the two, 1.1 moles divided by 0.0704 liters, and I come up with 16 molar. That's the C1. 16 molar is the molarity equivalent to 71% by mass. Now that I have the 71% by mass into molarity, this just becomes a C1V1 equals C2V2 problem, and I can figure out that I need to take 1.3 liters of the 71% by mass HNO3 and dilute that 1.3 liters all the way to 10.0 liters, and that will give me my 2.00 molar solution that I'm looking for. This problem is very, very similar to the hydrogen peroxide portion of your pre-lab. So if you're having trouble figuring out the H2O2 for your pre-lab calculations in solution 3, look really carefully at this problem and try to build one that's extremely similar.